This is Algebra 2, Lesson 2.4, Writing Equations of Lines. First thing we're going to do is write linear equations in different forms, and then we're going to use direct variation beginning on page 91 in the textbook. First thing is the definition of what is direct variation. It's when two variables, x and y, they show direct variation provided that y equals kx. You may or may not have seen this form of the equation before. K, if you notice, is in the same place where m normally is. Y equals mx plus b. When there's no y-intercept value, because y-intercept value is zero. But k can't be a zero number. That's what it means by a non-zero number, because if you multiplied x times zero, it'd be a horizontal line. It wouldn't vary directly. The constant of variation is the non-zero constant in a direct variation equation. So y equals kx, again, y equals mx plus b. This number right here, the m value as you look at it, which is not equal to 0. That's the constant of variation. How much is changing, how much is going up or down over how much it goes left or right. Again, that's just like slope. Then there's a box that says writing an equation. If something's in slope-intercept form, when you're given the m and the b, use the equation, or when you're given a slope and the y-intercept, use the equation y equals mx plus b. You simply say y equals mx plus b, and you plug in right here m, and you plug in right here b. And again, it's plus b because you're going to put either positive or negative there. That's when you're given a slope and a y-intercept, an m and a b. If you're giving a point and a slope, this is a point, there's no variable to represent that, and a slope, you're going to use point slope form. And again, it says x sub 1, y sub 1. Y minus y sub 1 equals m times x minus x sub 1. Remember from Algebra 1, it says minus for each of these. So whatever your x and your y values, or your sub 1 values for each of those is, it's going to be the opposite of whatever they say. So if this says negative 2, positive 3, for example, then in place of y sub 1, you're going to put negative 3. And in place of x sub 1, you're going to put positive 2. You're going to put the opposite of each of those. When you're given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, use the slope formula. Find the change of y over the change of x to find m. Once you have m, then you have a point and a slope. So you go back to this form right here, and you write it in point slope form, y minus y sub 1, or the difference of y and the value of the point, is equal to m times x minus x sub 1, or the difference between x and the value of the x variable in the point. Okay, here's example number 1. Writing an equation given m and given b. So it says write an equation of the line shown. First thing you want to do is look at the picture of the line and find out what your m value is. Now, oftentimes with these lines, you won't have highlighted points to use. What you need to do is you need to use points that go through intersections. What I mean by that real quick, if you have a graph and it goes through this point, then it goes through here, and it goes through here and here. Oh, that's terrible, I know. Let me see if I can do it a little bit better. What I mean by that is you want to use the intersections. For example, this is a good intersecting point because it's at x's value 3 and y's value 0. This right here is not a good intersecting point because it's not, you don't know what the x value is. You know it's somewhere past 2. The y value would be 1, but it'd be somewhere past 2. This right here wouldn't be a good intersecting point because it's in between lines 2. So you want to find the points, and I know this is a terrible line, but you want to find the points where you could identify both their x, in this case 1, and y value, in this case 2. And again, I know my line's not perfect, but that's the ones you want to find. Given this one, though, we have two highlighted points. We have this one here, and we have, we don't have 2 highlighted points. We have to Identify another one. This is a bad one because it's in the middle of 2. This, for the same reason, is a bad one. This is the next best one here. That's why it uses that one in the example. So you find the rise over the run, how much it goes up and down. In this case, it goes down 1, 2, 3. Down 3 we know is -3, over how much it goes left or right. In this case, it goes from left to right once, twice, 3, 4 times. So it'll be over 4. And that's why the slope comes out to be -3 over 4. It doesn't matter if you put the negative at the top or the bottom. Notice right here they have it written in the middle. It means the same thing. Make it easy on yourself. Don't put it up there at the top with number 3. That way you'll never go to the left with your equation. You'll always go to the right. Down 3 and to the right 4. Then it says the line intersects the y-axis at point 2. So, or at 0, 2. This value right here, its y value, or in this case, its b value, is 2. That's the b. And it's positive, so you have a b value of 2. So you have an m and you have a b. So take your equation, y equals mx plus b, and you plug in m's value, which is this one here, m right here, -3 over 4, and you plug in b's value, which is this one right here, +2. And that's your equation. Y equals -3/4 x plus 2. Okay, in the white space off to the side, because there's no back, everybody, do this line right here. Take about 45 seconds. All right, who got y equals 2x minus 2 for this one? Really easy, everybody. Identify 2 points. Always try to identify this one and let it be one of your points, because you're going to need that one anyways. That's going to be your b value right there. That b value is -2. From there, find out what your slope is. We need to find one more point we can use. This is a bad point because it's in the middle of 2. It's halfway in the middle, but it's still an estimate. This is a good point. If you didn't use this one, you could have used this one. You could have probably used this one. You could have used this one. But we identify the ones that are closest to make it easy for us. So from there, you're going to go how many times you're going up or down. From here, we're going up once, twice. Up 2 is +2. Over how much you're going left or right. You're going to the right 1 time, +1. So that's your m value, 2 over 1. Y equals mx plus b. M's value, we just said, is 2 over 1. There's no reason to write anything over 1. So m is 2. And b's value, we said a minute ago, was -2. 2x minus 2. Okay, here's writing an equation given the slope and a point. Now we don't have the slope and the y-intercept given to us. We have the slope and we have a point. So here is our slope value, 2. That's an m. Our point, this is our x, this is our y. So this is going to be sub 1 for each of these. Now your point slope form is y minus y sub 1 is equal to m times x minus x sub 1. All we have to do for this one is put y minus y sub 1 equals m times x minus x sub 1. We have to fill in 3 different values. Your m is the easiest thing to fill in because you don't have to change anything about your m. This is your m right here. and we said the m value is 2. Remember, for your x sub 1 and your y sub 1, it's going to be the opposite of whatever the point says. The x sub 1 value is 1, so we're going to put the opposite, -1. The y sub 1 value is 2, so we're going to put the opposite, -2. So that's what your point slope form should look like. Y minus 2 is equal to 2 times x minus 1, point slope form. It says once you have used the point slope form to find an equation, you can simplify the result to slope intercept form. We can make slope intercept form. So y minus 2 equals 2 times x minus 1. We know we can distribute 2 to both of these. So you get 2x minus 2. So y minus 2 equals 2x minus 2. And then add 2 to both sides to get y by itself here is equal to 2x. When you add 2, you get plus 0, which is the same thing as simply y is equal to 2x. And again, that line right there in the middle is just written in the horizontal form, or that's not written in the horizontal form. It just leaves a step off. It just shows you each solution step. It doesn't show you the arithmetic, just like I did. So given a point and a slope, put it in point slope form, and then you can convert that to simplify it into slope intercept form. Again, on the side or in the white area, write this equation given this point, -3, 4, with the slope of 2/3. Y minus y sub 1 is equal to m times x minus x sub 1. Take about 45 seconds. Y minus y sub 1 equals m times x minus x sub 1. We're going to fill in each one of those values. M is the easiest one for everybody to fill in because it's your slope. So in place of m, we're just punching in or we're filling in 2/3. Okay. For the x and y sub 1s respectively, it's the opposite of whatever this says. This says x sub 1 is -3. So in place of x sub 1, we're going to put positive 3. You put the opposite. The y sub 1 is 4. It's positive. So in place of the y sub 1, we're going to put in -4. There is your equation in point slope form. Take another 30 seconds from here and make this say slope intercept form. First thing you need to do is distribute 2/3 times x will be 2/3 x, and 2/3 times 3. If you need to write it off to the side, do that. Times 3. Remember, everything's over 1. These cancel each other out. You're left with positive 2. So y minus 4 equals that. Not quite mx plus b. We got one more thing. We have to undo -4 by adding 4 to both sides. You only add it to the like terms. So y is equal to 2/3 x plus 6 is your slope intercept form. Mx plus b. And then parallel and perpendicular lines is next. Remember, parallel lines have the exact same slope. Perpendiculars are opposite reciprocals or negative reciprocals. Write an equation of the line that passes through 2, 0 and is perpendicular and parallel to the line y equals 2x minus 1. So when you look at this equation, y equals mx plus b, you can identify the m value right away. It's 2. And that's what it says. The m, or the slope of line 1 or line sub 1, is equal to 2. So a line that is perpendicular, if it's 2 over 1, remember you have to do two things to that. You have to flip it, 1 over 2, and you have to change its sign or opposite. Positive 2 becomes negative 1 over 2. So a line that is perpendicular has a slope of negative 1 over 2, or negative 1/2. It says, so now we have a slope. We have negative 1/2, and we have a point, 2, 0, that was given to us in the problem. So that's x sub 1, y sub 1. X sub 1 right here, y sub 1. We're given a point and a slope. So y minus y sub 1 equals m times x minus x sub 1. Your slope is exactly what it says. You don't have to flip that one or change it. Negative 1 over 2. Your x value is the opposite of 2, which is negative 2. And your y sub value is the opposite of 0, which there is no opposite of 0. It's just plus 0 or minus 0. So let's look at that for a second. Minus 0. So y minus 0 equals negative 1/2 x minus 2. So when you use the distributive property, this is point slope form. But when you use the distributive property, you come back to slope intercept form, y equals mx plus b. For a line that is parallel to the instructions that goes through the same point, you don't have to do as much work. Again, you know the m value is 2. So you're going to use that value 2. Oh, keep scrolling down. Thought there was more to it. There is. Must have cut it out. But for a line that's parallel is the second part. Here is your m value 2. Okay, so your m is 2. It's going through the same point, 2, 0. So using the point slope form, I know it's missing on my screen, but you have it on your sheet. Y minus y sub 1 equals m times x minus x sub 1. We're going to do the same thing. The only thing that's different about this one is your m value, which is 2. So it's going to go there. It'll still say x sub 1. The opposite of that one is negative 2 or minus 2. And the opposite of y sub 1 is negative or minus 0. Again, there's no such thing as negative or minus 0. So your equation should say, when you use the distributive property, y is equal to 2x minus 4 in that last line. Y equals 2x minus 4. Okay, real quickly in this white space, let's do this one. Write an equation of a line that passes through that point. One of them that's parallel, or one of them that's perpendicular. The other one that's parallel. Take about 1 minute. Okay, we'll do these real quick. Looking at this equation, y equals mx plus b, its m value is 2. So when you want a parallel line, you're going to use that exact same m value. When you want a perpendicular line, you're going to flip 2 over 1, and it's going to become 1 over 2. And it was positive, so it's going to become negative. So that's the line that's the slope you're going to use for that one. We're going to use the same form because we're given a point and a slope, x sub 1, y sub 1. So y minus y sub 1 equals m times x minus x sub 1. Same thing here. Minus y sub 1 equals m times x minus x sub 1. We're going to plug the same thing in place of our y sub 1 for each of these. The opposite of negative 3, so positive 3. And we're going to plug the same thing in place of our x sub 1, the opposite of positive 2, negative 2. The slope is different. This slope value for the parallel line is positive 2. This slope value for the perpendicular line is negative 1 over 2. And those are your lines in parallel and perpendicular form passing through that point 2, negative 3. And we will cover the rest of this tomorrow.